Hello again everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video we will go through these checkpoint questions, which are all based on selected past year paper questions from atomic structure. This is for the chemistry 5070, which is basically the Cambridge International all-level exam, suitable for 14 to 16 years old chemistry learners, and these are also applicable to IGCSE or GCSE chemistry curriculum. Whether you're doing the core or the extended curriculum, atomic structure is a key topic, and they tend to be included in whichever core or extended curriculum that you're doing for your examination. All right. So in this first question, we have an oxygen atom containing 8 electrons, 8 protons and 10 neutrons. We are told that this is an atom. So in an atom, as you could see, the number of electrons and protons are the same because we have an atom. So the charges on the proton must be balanced out by the charges of the electrons. Hence, you have equal number of proton and electrons in an atom. They are asking us for the nucleon number. So nucleon number is the number of protons plus the number of neutrons in the nucleus of an atom. That's the definition, right? So nucleon number will be number of proton, which is 8, and the number of neutron, which is 10. So number of proton plus number of neutron will give us 18 nucleons. So nucleons refer to the sum of the number of protons and the neutrons in the nucleus of an atom. Question 2, you have an element X. It forms a positive ion with the electronic structure 288. So 2 electrons in the first shell, 8 electrons in the second shell, and 8 electrons in the third shell. All right. So first of all, when you form positive ion, you must have lost electron to form positive ion. Because you lose electrons, you lose negative charge. If you lose negative charge, you will have more positive charge than the negative charge because the number of protons is still the same, but you have lost the electrons from the atom of the element. Just like previously, in an atom, number of electrons equal to number of protons. When you lose electrons, you will have more protons than electrons. That's why you have a positive charge. Positive ion is a result of losing electrons. All right. So 288 is having lost the electron. Having lost electrons. All right. So 2 plus 8 plus 8 is equal to 18 electrons. And that is a result of you having lost the electrons and you become 18. So what is the proton atomic number of X? All right. If you lose electrons and you have 18 electrons now, you are a positive ion. And you are positive ion because you have more proton than electrons. So if you have 18 electrons, you cannot have 18 proton because that would mean no overall charge. That would mean you have an atom. But you have an ion, and this ion has the 18 number of electrons, and we know there are more proton than electron because it's positively charged. Therefore, the best answer must be 19. It has more protons than the electrons, and therefore you're positively charged. Okay. Number 3, helium is the second element in the periodic table. Tritium is the isotope of hydrogen. So if it is an isotope, that means the proton number is still the same, the identity of the element is still the same. So in your periodic table, you will have seen this being the other way around. So for an isotope, we always write the mass number on top, but in the periodic table, relative atomic mass is written at the bottom. So you need to be aware of the different convention, the different standard of how chemists represent isotope. Yeah? 3 is the mass number for the isotope. At the bottom, this is the identity of the element. Identity of the element is the proton number. So I write down hydrogen 1 because it's the first element in the periodic table. Helium, on the other hand, is the second element. That's why the proton number is 2. And we are talking about helium 4. So 4 is the mass number. So by looking at this, we know that these are the nucleon number. I should probably label it nucleon number. We call that mass or nucleon number. And then at the bottom is just number of protons, yeah? So what is the same? Well, I work out the number of protons first. There is 1 proton and 2 protons. Because these are the identity of the element, they follow the proton number. Proton number 1, only 1 proton. Element number 2, proton number 2, 2 protons, okay? Then we look at the electrons. We are looking at atom and atom. When you have an atom, the number of protons equal to number of electrons because their charges balance out. That's why you do not get an ion. You get an atom where there are no overall charge. So number of electrons equal to the number of protons. Next bit is the neutron. Number of neutron is going to be nucleon number minus proton number. So it's 3 minus 1, 2. It's 4 minus 2, 2. So what is the same? Number of proton is different, number of electrons is different, number of neutrons is the same. So number of neutron is the same for both the helium-4 atom and the hydrogen-3 atom. Okay, so it all comes down to reading questions and setting out these proton, electrons, and neutron kind of simple table and working them out individually, and being able to do this very quickly comes down to whether you're able to write this formula based on your knowledge from the periodic table, based on how fast you can find hydrogen and helium from the periodic table as well, yeah? Question 4, the formula of the ions of 4 elements. So these ions of 4 elements. The element here is oxygen, fluorine, lithium, and magnesium. But these are ions. These are -2. These are -1. So we say that these have gained electron. The atom has lost electron. Okay, so the atom gain electrons. The atoms lose electrons. So you have more proton than electron. That's why you have positive charge. The atoms gain electrons, so you have more electrons than proton. That's why you have negative charge. Okay, so what about them is correct? What about them is correct about the ions? So if you look at it, they are to do with protons, electrons, electronic structure. If I were you, I would really set up this kind of proton, electrons kind of table. I don't think I really need the neutrons because none of the question is asking us on the neutron. So I'll just set up proton and electron, yeah. Oxygen from the periodic table, I hope you can see the proton number is 8. Fluorine is 9. Lithium is 3. And magnesium is going to be 12. These are obtained from the periodic table. They are the proton number: oxygen, fluorine, lithium, magnesium. If I scroll up to my periodic table, oxygen proton number is 8. They even told you atomic number, which is proton number. So different names but the same meaning. Proton number 8, proton number 9, proton number 12, and I forgot what was the other one already. Oxygen, fluorine, magnesium, and lithium. Element number 3, proton number 3. Okay, so these are ions. As I mentioned, they have gained electron. Here the atom is supposed to have 8 electrons, where then you have equal number of proton and neutron. Then you have oxygen atom, which is not charged, but you have a 2 minus. That means you have gained 2 extra electrons. Therefore it's 8 plus 2, you get 10. When you have a -1 charge, is because you have gained electron. You have more electrons. You have more electrons than proton. You have 2 more electrons than proton. You have 2 minus. You have 1 more electron than proton. You have -1. Plus charge is a result of you losing electron from the atom. So it's going to be minus. Minus how much? -1. Because now you have 1 extra proton than the electron. You have a +1 charge. And for this is 12 minus 2 because you have a 2 plus. That means you have lost 2 electrons. Now you're just going to have 10 electrons. And you have 2 extra protons than electron. That's why you have a 2 plus charge, right? Over time, this should hopefully get easier and easier for you. But you gotta get used to this kind of thing, yeah? So we're looking for a statement about these ions. So these are the proton and electron count for these ions. Same number of electrons in their outer shell. Same number of electrons in the outer shell. I can tell you this is wrong because look at lithium. Only 2 valence electrons. So A is incorrect because lithium only has 2 electrons in the outer shell. Alright. How about B? The same electronic structure as a noble gas. So O2 minus is 10 electrons. So oxygen gain 2 electrons, become 10 electrons, 10 electron, 10 electron. These 2 electrons. So noble gas helium will have 2 electrons because the atom will have equal number of proton and electrons. Neon atom will have 10 electrons because a neon atom will have equal number of protons and 10 electrons, therefore, because in an atom there is no overall charge. Alright, so helium has 2 electrons, neon has 10 electrons. So in terms of electronic configuration, this one has the same configuration as neon, neon, neon. This one has the same configuration as helium. These are noble gas electronic configuration. Okay, so they do have the same electronic structure as a noble gas. Alright, same number of protons in their nuclei is incorrect because all are still different elements. So number of proton tell you the uniqueness, the characteristic nature of the element. Different element would mean different proton number. If same proton number means same element. These are clearly different ions of different elements. Alright, more electrons than protons, more electron than proton, more electron than proton. This one, because they are positively charged, they have more protons than electrons. Okay, this is incorrect because we also have positive ions. Positive ions would mean the number of proton is more than the number of electrons. How do you get positive charge? Because you have more proton than electrons. So this is not correct for all of the ions. Number 5, which atom, okay, so you're looking for an atom, has the same electronic configuration as the strontium ion. Strontium is in group 2. That's why it's important to know your periodic table. Okay, so periodic table, if you have time, you should go through your periodic table and look through the elements, look through the name and look for the symbol. Now I know strontium is in group 2. It's easy to see is SR. Okay, it's the first, second, third, fourth, fifth. Is the 5th period and it's group 2 strontium SR. Because it's group 2 element, it likes to form +2 ion because it likes to become the noble gas argon there. Okay, so it likes to lose 1 electron and then lose another one, and it will have argon configuration. If it likes to lose electrons, it will form positive ions. So by losing 2 electrons, you get to argon configuration, and therefore strontium will form strontium 2+ ion. Alright, so there will be strontium 2+. Strontium is group 2. Okay, so if I lose 2 electrons, I will get to the noble gas, which was krypton. Okay, Kr. So I'm looking for krypton because if calcium ion will like to form Ca2+. In fact, we are not looking at calcium ion because this question is saying which atom. Okay, so this one is group 2, this one is group 1, this one is group 6. Oops, sorry, I should use the other kind of numeral. This one, okay, there's group 6. Okay, calcium, rubidium, selenium. Calcium is there, group 2. Selenium is there, group 6. Okay, group 6 selenium, and the other one is rubidium, group 1. Okay, so these are not numbers, these are the Roman numerals, so you need to honor, you need to respect the way the periodic table has already shown it to you like this, and you have to use it in your wording as well as in your application as well. Yeah. So obviously krypton is the only one that matches the electronic configuration of strontium because this will have 2 electrons in the outer shell, 1 electron in the outer shell, 6 electrons in the outer shell, 8 electrons in the outer shell, the same as strontium ion. Number 6, the letters X, Y, and Z represent different atoms. So these are atoms. What can be deduced from the proton number and the nucleon number? The nucleon number also has another name. It's called the mass number. So if I just set up my table, my proton, electrons, and neutrons table very quickly. Proton, I have 19 proton, 20. So I can tell element X and element Y is the same because they have the same number of proton. This proton number 19 is different from element 20 because they have different number of proton. All right. Electrons. This one they already told us is atom, so no overall charge. If no overall charge, the number of proton must be equal to the number of electrons in an atom. That's why there is no overall charge. These are atoms with no charge at all. So number of electrons must be equal to number of protons, right? Number of neutron is the difference between the mass number, or what you call the nucleon number, the bigger number. Again, your periodic table will show you the other way around because that's the way the periodic table is, where the proton number is on top. But here, these are how we represent isotope exactly. Yeah, okay. So typically in a question, they will always represent in this way, where the mass number or nucleon number is on top, just like it's how it was stated in your syllabus as well. You need to know them. Okay, it's ridiculous, I know, but it's not like I could change this at all. Yeah. So the difference between the mass number or nucleon number and the proton number will give you the number of neutrons. So 40 minus 20 is 20. So what can we say? What can we say? Yeah? What can be deduced? What can be deduced? What can be concluded is the same thing. Yeah? X and Y are the same element. Well, same number of proton, right? Same number of proton. So I can tell you they are the same element. X and Z are the same element? Nope. Because different number of proton. Of course, you have to spell out the number. Yeah? Okay, I use the hash sign to represent number because I can abbreviate in my explanation. All right. X has more proton than Y. They have the same number of protons, right? They have the same number of protons, so more is actually incorrect. Z has more neutrons than Y. Z has the same number of neutrons as Y. Z has the same number of neutrons as Y based on what I just shown you in my calculation. Question 7 is one of those things that are new in your syllabus starting from 2023. They started to incorporate this kind of this is actually like it used to be covered only in the first year of A-level, but it seems that they're trying to make O-level a bit more challenging by incorporating this idea on the mass spectrum of the individual isotope. So we know that isotopes are atoms of the same element with the same proton number but different mass number. So what can we say? This is actually 90x, 91x. So actually we will pronounce it x90, x91, x92, x94. So they have different masses and they have things called relative abundance. Relative abundance or the percentage abundance. That is 50%. That is 10%. This is 20%. And this one is roughly 20%. Okay. 50 plus 10 is 60, plus 20 is 80, plus 20 is 100%. So these are the total number of isotopes are present in different amount, in different abundance. Relative atomic mass is defined as the average mass of an atom of X relative to 1/12 of the mass of an atom of carbon-12 isotope. So the definition is required in the syllabus. It is relative to 1/12 the mass of an atom of carbon-12 isotope. So make sure you can define them. Yeah. But this question is asking you how to work out the relative atomic mass, which is basically the average mass. Okay, the average mass of an atom. So I have isotope number 90. That is the mass multiplied by the percentage. So 90 times 50, and then the mass, and then I sum them up. The mass of the isotope 91 times 10, and then the mass of isotope 92 times 20, and then the mass of isotope 94 times 20%. I want the mass, right? I want the mass, which is the x-axis, so I will divide by the sum of the percentages. The sum of the percentages will be 50 plus 10 plus 20 plus 20. Actually, I know it was 100% because I already shown it for you. If I were you doing this kind of calculation, make sure you use bracket carefully and make sure you do your calculation this way first instead of putting everything into your calculator. So 90 times 50 plus 91 times 10 plus 92 times 20 plus 94 times 20. So I got 9130 and I got 100% at the bottom. So that will give me 91.3. Okay, so the only one which matches what I have gotten is 91.30. So that is the relative atomic mass, which is the average mass, and it lies somewhere in between the lowest value and the highest value of the mass. Okay, so it makes sense then. Question 8. Naturally occurring bromine has a relative atomic mass of 80. So this is from your periodic table. And they consist entirely, or you can say only of two isotopes. Okay, the relative atomic mass is 79 and 81. And then what can be deduced? Deduced means what can be concluded about the naturally occurring bromine from this information only. Bromine contains the two isotopes in equal proportion, i.e. 79 bromine and 81 bromine. Equal proportion means 50%, 50%. If you have 50% of this and 50% of this, then your average mass is in between, which is going to be 80, and that makes sense, and I can show it by calculation, but in fact I don't need to. If you can understand the meaning of the term average, you should be able to see that I can also do the calculation and still get the same thing. 50% abundance of each because equal proportion, because only of two isotopes. 79 times 50 plus 81 times 50. I will do bracket because naturally I am careless, so I want to minimize my mistake. So this is 8,000 divided by 100 because 100 is the sum of the 50% and 50%, and that gives me the relative atomic mass, which is the average mass of the isotope relative to 1/12 the mass of an atom of carbon-12. So option A is the best deduction that you can make. All right, oxidation state doesn't really make sense because these are elements. All right, so you will learn more about oxidation number later on in a later topic. Okay, different number of proton is incorrect. Both still bromine. If you are still bromine, you are still the same element. If you are the same element, how can you have different proton number? Okay, and bromine is not radioactive at all. Radioactive means unstable nucleus. So when you have unstable nucleus, you want to break up and form elements of smaller nucleus. Okay, and bromine isn't that, because bromine is one of two liquids at room temperature and pressure and is stable enough to exist as such. All right, so bromine is one of two liquids at room temperature and pressure at 25 degrees Celsius, the other one being liquid mercury. Question 9, you have an atom contains 16 protons. So if the atom contains 16 protons, look for element 16. And element 16 in the periodic table, proton number, right? Element 16 is going to be sulfur. The symbol is S, okay? And sulfur is in group 6. Vi refers to 6, right? So sulfur is group 16. Oops, sorry, not 16. Group 6. I keep on referring to 16 because it's how A-level would do it. But since you're in O-level, given your periodic table, do whatever your periodic table tells you to, okay? Which statement is correct? So it cannot form an ion. That is wrong, because group 6 prefers to gain 2 electrons. Why? Because you want to get to the noble gas configuration. 6 outer shell electrons gain 2 electrons. It wants to form the ion. Alright, 6 electrons in the outer shell, group 6. That is correct. Okay, contains 6 neutrons. You cannot tell. Okay, can't tell. But from periodic table, what you have is you have 32 and 16. So the difference, the 32 there minus 16 will give you 16 neutrons. Okay, 32 minus 16 will give you so sulfur from your periodic table. It's going to be 32 and 16. So number of neutrons is equal to 32 minus 16 is 16 neutron. Okay, so 6 neutron is incorrect. And then it has a relative atomic mass of X16, and that is again incorrect. It's 32 as shown from your periodic table. All right. Question 10. So they give you two atoms. So these are atoms. They are not isotopes because this is phosphorus. Phosphorus is group 5. That other one is sulfur, is group 6. You should know your first 20 element inside out. Okay, I'm not kidding, because if you don't know your elements, then you will have problem. Okay, number of protons is the dependent on the proton number, so it's 15 for phosphorus, 16 for sulfur. These are atoms. Atoms mean no overall charge. Why are there no overall charge? Because the number of proton equal to the number of electrons, so the charges get cancelled out. The whole atom doesn't have any charge, therefore the number of electrons equal to number of protons. So here also has 16 electrons. Number of neutron is the difference between the mass number and the proton number. So 31 minus 15, you will get 16. 32 minus 16, you will get 16. All right, so what do I know? Same. So you're looking for same, yeah? Same nuclear number is wrong. 31 is not the same as 32. Number of electron is wrong. 15 is not the same as 16. Look at the number of electrons. Number of neutron is the same. 16 is equal to 16. Okay, so here we are, number of neutrons. And we already gotten the answer. Number of protons is definitely different. These are different elements. Phosphorus versus sulfur. Different element, how can they have same proton number? Cannot, right? Okay. Question 11. Which statement is correct? So you always have to read the question, yeah? Is correct. Apart from hydrogen, other than hydrogen, except hydrogen, except or other than hydrogen, most atoms contain, what do we have? We're talking about atoms. So again, atoms, no overall charge, number of proton equal to number of electrons for atoms. So I can tell you C is incorrect and D is incorrect because number of proton equal to number of electrons for atoms, because atoms have no overall charge. More protons than neutrons. This is unlikely, because if you look at your periodic table, proton is the one that keep on increasing by 1 as you fill up the periodic table. Neutrons is the difference from the mass number or the nucleon number with the proton number. So if you look at your periodic table, you will see that apart from hydrogen, so the number of neutron is actually 0 because it just has 1 proton and 1 electrons. Here the nucleon number is bigger than the proton number. Nucleon bigger than proton. Nucleon, or what you call the mass number, bigger than proton. All the time your proton number is always smaller than the nucleon number. Your nucleon number is actually the number of protons and neutrons. So here you can see that there are six neutrons and 6 proton, 7 proton and 7 neutrons. So it looks to be almost equal, but as you go further and further, you will see that the number of neutrons increases. Like 65 minus 30 is 35. 35 neutron versus 30 protons. As you go further and further, the number of neutrons exceed the number of protons. So there will be more neutrons than protons if you understand the periodic table. Okay, so apart from hydrogen, which has 0 neutron, most atoms will contain more neutrons than protons. All right, we have come to this structured level kind of question. So question 12 is about filling in the table. These kind of questions are very popular in the structured paper because, you know, other than the theory level MCQs. Here is where you can ask you to basically work out the number of proton, neutron, electrons, where they give you the table. That was what we have been doing for the multiple choice question. All right. So if you look at the element is calcium, and here the symbol tells you the element is chlorine. If you look in your periodic table, calcium is element 20, chlorine is element 17. This is group 2, this is group 7. I better write this properly. Group 7. Okay. Now that is not proper. That's much better. Group 2 and group 7, calcium and chlorine. I shouldn't be flicking back and forth to the periodic table, but in case you don't know where to find them, you really must know at least the first 20 elements, and then going down the group, you should know a little bit more about the elements and at least where you find them. At least familiarize yourself with the name of any other elements, but the first 20 you've got to know them. All right, otherwise you will struggle going forward unless you know the elements in the periodic table. Okay, the proton number depends on the proton number. So if I put in the proton number, there's 20, then there's 17, so there's 20 proton, 17 proton. The number of neutrons is the difference between the mass number or the nucleon number on the top. So there's 40 minus the proton number, which is 20. 37 minus 17, which is 20. Electrons are tricky here because these are ion. Be careful, yeah, ion, not atom. If you have atom, then you have 20 electrons. But you have a 2 plus. You have a 2 plus because you have lost electrons. You have more protons than electrons. That's why overall you have plus charge. You have lost 2 electrons because you have a 2 plus. So you have lost 2 electrons. You have 2 extra protons than electrons. You have a plus 2. You have a negative charge because you have gain electron. Gain electron. Gain how many? Gain 1 because it's a minus 1 charge. So overall now you have 18 electrons. You have 1 extra electron than proton. That's why you have a minus 1 charge. Shouldn't be that difficult, and it takes 1 mistake for you to lose any of the 2 marks. Yeah. Question 13 is basically putting into word what I keep on saying, why an atom is electrically neutral in terms of subatomic particles and their charge. And they are specifically asking you this example. So in a question, it's not just stating what you memorize, which is basically, in an atom, number of protons and number of electrons. No. You have to use this particular example because they say use this example, and you have to explain it in terms of the number of protons and electrons and their charges. Okay. So for an atom, I'm talking about atom of 9843 Tc. Okay. There is no overall charge. So as protons are positively charged, so I'm talking about the charges now, and electrons are negatively charged, number of protons equal number of electrons in an atom of 9843 technetium. Okay, so 9843 technetium has 43 protons and 43 electrons. So if you just state number of protons and electrons, it's not enough because you are not talking about their charges, which I have just mentioned, and I also need to say they must equal in number for the charges to be overall 0. No overall charge means the overall charge is 0. So one of those statements you have to make it in order for it to be clear and to fully gain the 2 marks. Okay, so I mean, a lot of people will just counter this, but you've got to explain. The question really asks you to explain and not just stating. Yeah. Question 14. So this is about chlorine. Chlorine existing as 2 isotopes. So chlorine has 2 isotopes, just like bromine just now was bromine 79 and bromine 81. Those are your case study. If you see in the periodic table, the relative atomic mass of chlorine is 35.5. Let me show you. Relative atomic mass, remember, is average mass. You see a relative atomic mass is actually average mass, and it's 35.5. Okay, 35.5. There's no such thing as half a neutron, but because it's a relative atomic mass, it's to do with the average mass of all the isotopes present, relative to the mass of an atom of carbon-12. The 1/12 of an atom of carbon-12 is very important in the definition. Yeah. Here, you are given the atomic mass and you are asked to work out percentage abundance. Earlier, we saw a couple of questions where we don't know this, but we were given the percentage abundance and we need to work out the relative atomic mass. So if I have two isotopes, so if the percentage of 35 chlorine is X, therefore the percentage of 37 chlorine is 100 minus X. Percentage is out of 100%, just like your exam marks, and there are only two isotopes. If this is X%, then the percentage of the other one must be 100 minus X. Okay, and we know that the mass of this is 35 and is present in X%. The mass of this is 37, this is the mass number, and is present 100 minus X. And we know the average is 35.5. So this is a bit of algebra. 35 times X is 35X. 37 times 100 minus X is 37 times 100 minus X. Use big bracket to avoid making mistake. Then you have X plus 100 minus X. Essentially, this is the sum of the percentages, which is equal to 100% anyway. Okay, and that is equal to 35.5. Previously, you know all of these. You know the percentage abundance. Then you work out this thing. Here, you don't know the percentage abundance. We use algebra, but we know the relative atomic mass, which is given, and also from the periodic table, we can work out the percentage abundance by doing a little bit of algebra. Yeah? The X and the X cancel. At the bottom is just 100%. I can bring up the 100 to the top, so it's 100 times 35.5. This is your simple maths. This is expansion. Expansion is something that a lot of people couldn't do properly, especially if they don't use bracket, and bracket is very, very important. Okay, maybe I'll write in pink, then you can see 3700 minus 37x. I can clearly see 35 minus 37 is negative, so I will move the 37x minus the 35x to the right hand side. I will keep the 3700 on this side, and I'll get 3550. You get this time 100, you get 3550. Okay, then I will flick the 2x from the right to the left, and then do 3700 minus 3550. That is 150. X is 150 divided by 2 because it is 2 times x, so 2 go to the other side is divide, and that is 75. And it has a unit because what is x? That's why it's important. X is not just x, alright? That's why we wrote this down. X is the percentage of 35 chlorine, but the question asks for each isotope, alright? So therefore, the percentage of 35 chlorine is equal to X is equal to 75%. And if they're asking for each isotope, so that is 100 minus X, the difference, which is 25%. You have 3:1 ratio. This is another case study. Chlorine is to 37 chlorine is 3:1 ratio, whereas previously you have 79 bromine is to 81 bromine, which is 1:1 ratio. 50-50 in an earlier multiple choice question on this checkpoint. We also have this 1:1 ratio for the bromine. That's why our average mass is in between, which is 80. Our average mass is not in between, it's not 36, because I have a lot more of chlorine 35. I have 75% of chlorine 35. I have only 25% of the heavier one. So my mass is 35.5, which is closer to the one that I have a lot more of. Alright? I think that is the end of these tutorials on checkpoint questions involving atomic structure. So if you got any questions, do raise with me, and I'll try to help you in class or during break time or whatever. But yeah, if you enjoyed the tutorial, don't forget to subscribe and share the channel with friends, your juniors, your seniors, or relative, or whoever else you think the video or the channel might be useful for. And I'll see you in the next video. Thank you for watching.